Hello there, Algebra 1. I apologize. This video was uploaded a little bit later than I was hoping to, but I hope it'll still be a help to you. Let's go ahead and get started here. We're gonna be skipping a lesson or two. I can't remember. I'm not looking at the initial right now, but we're gonna skip down to the lesson that's called the substitution method. And I just want to basically give you 3 examples, and hopefully these will be a help to you. All right, so with the substitution method, as you can see here, we actually have 2 equations: y equals 2x minus 3, and then x plus y equals 3. All right, so in order to solve any equation, you can't have 2 variables. Okay, if you only have 1 variable, then you can solve for whatever that variable is. Okay, but right here we have 2 variables here, and we have 2 variables here, and so what we've got to do here is we're going to use the substitution method to give us a value for one of the variables. All right, that way we can solve. So let me show you. I'm just going to kind of show you how this works. Now this one actually starts off pretty straightforward. If you look at this first equation, it actually says that y equals 2x plus 3. So what is the value of y? Well, it tells us the value of y is 2x plus 3. So the reason this is called the substitution method is because I'm going to take the value of y right here, which is, again, y equals or is, and then here's the value. It's 2x minus 3. So I'm going to take this, and I'm going to substitute it in for this y right here. Okay, so this is actually a system of equations. Okay, so I'm going to rewrite this second equation here, x plus y equals 3. And when I do, I'm going to substitute 2x minus 3 in for y. Okay, so it looks like this. It's going to be x plus, and instead of putting y, I'm going to put 2x minus 3 equals 3. Okay, so everything here is just this right here, except for instead of putting y right here, I put the value of y. So y equals 2x minus 3, and I just put that in for that y right there. Okay, so now check it out. So now I can combine like terms right here, and that gives me 3x minus 3 equals 3. And now we're dealing with just one variable. So I can actually find out what the value of x is. All right, so how are we going to do that? Well, we're going to add 3 to this side, add 3 to this side, and that gives me, those cancel out, right? So 3x equals 6, divide both sides by 3, x equals 2. Okay, see that? Okay, now, so check this out. Now I can take x equals 2, and I can actually plug it in. I can plug it into either one of these equations. I can plug in my value of x. I can either plug it in here or I can plug it in here. So I'm going to plug it in. I'm going to plug it in right here. So I'm going to take 2 plus y equals 3. Okay. Now I'm going to solve for y. So I'm going to subtract 2 here, subtract 2 here. Those cancel out. And I'm going to bring this over here. So y equals 3 minus 2 is 1. Okay, so I have all of your answers to your problems are going to have 2 parts. There's going to be an x value, and there's going to be a y value. And we can actually write this as an ordered pair, where x is 2 and y is 1. Okay, now we can check this out. We can check our work and make sure it's correct by plugging in both of these. So if I plug in the value for y in for here, and I take my value of x and I plug it in for here, then I should get these equations should balance out. Okay, so I'm going to try that. So for y, I'm going to put in a 1. So 1 equals, okay, 2 times x, we said, is 2 minus 3. Okay, so all I did was I took this equation and I just plugged in my value. So instead of y, I put in 1. So 1 equals, okay, then I've got 2 times x, so that's 2 times, okay, then I put 2 in right there, and then minus 3, minus 3. So check it out. We got 1 equals, okay, 4 minus 3, 1 equals 1. All right, and then I'm running out of room here, but actually if we plug it into the second equation, it's also going to work, right? So 2 plus 1 is 3. So it checks out for both equations. All right, now let's try another one that's a little bit more. Well, this may not be too bad actually. All right, so we see again we have 2 equations, and the second equation we actually have a value for x, right? X equals y minus 3. So what do you think we should do? I'm going to give you a second to think about that. What do you think we should do? What do you think we should do? Exactly, yes. It's exactly what I was thinking. We're going to take y minus 3, because it's the value of x, y minus 3. We're going to plug it in for right there. Right that. That makes no sense. Right there. Okay. So I'm going to rewrite the top equation. Zoom out a little bit. So it's going to be 10 times y minus 3 plus 10y equals 1. Do you see what I did? I just put this in for that. Because, well, why did I do that? Because it tells me x equals that. So I'm going to plug it in for that. This, remember, substitution method. Okay, now what should we do? We're going to distribute, right? So it's going to be 10y minus 30 plus 10y equals 1. Okay. So now we can, remember, now we're down to just one variable left, which means, what does that mean? That means that we can solve it, that we can solve for y, right? So we're going to combine our like terms here. So we have a 10y and we have a 10y. So that's going to give us 20y. So we've combined these. Minus 30 equals 1, right? Okay, now if we want to, we're going to add 30 to both sides. And we get 20y equals 31. Divide both sides by 20. Oops. Okay, and we get y equals 31 over 20. They're not always going to be like nice, pretty numbers all the time. So actually go back and check our work here, make sure we did it right. So we plugged in our y minus 3 in for x. That gave us 10y minus 30. Okay, plus 10y equals 1. We combined our like terms. That gave us 20y minus 30 equals 1. We added 30 to both sides. We got 20y equals 31, divided both sides by 20. So we got y equals 31 over 20. Okay, now that we've got a value for y, we can go ahead and plug it in. And the easiest one, I think, to plug it in for would be this one right here. All right, we could actually plug it into this one as well, but it just seems like that's going to be a little more work. So I'm going to plug in 31 over 20 in for this y. All right, so that's going to give us x equals, okay, 31 over 20 minus 3. Okay, and I'm going to put that over 1. All right, so if we're going to do subtraction, that'd be 31 over 20 minus 3 over 1. Okay, we need a common denominator, don't we? It's going to be 20. So this actually would stay. This would just be 31. Okay, and then 1 times 20, 3 times 20 is 60. All right, now we got this 31 minus 60. Okay, well, that's going to be negative 29 over 20. Okay, and then so that means that x, if we took, so right here, x equals negative 29 over 20. All right, so now let's check our work and see what we get. Okay, so I'm going to go up, the easiest one to check our work with would be this one right here. So if I plug in my values, so if I take negative 29 over 20 equals, okay, now we're going to take 31 over 20 right here, right? We're going to plug that in for y. So what do? We took our value for x, plugged it in for x right here, our value of y, and we're going to plug it in right here. So 31 over 20 minus 3. Okay, and what are we going to get? Well, notice that's the same thing that we actually just did right here. 31 over 20, right here, 31 over 20 minus 3 gave us negative 29 over 20. Let me make sure my math is right on that. Yep, so if we, 31, 60, yep, and that would be negative. Okay, all right, let's double check it in the second equation. So our value for x, again, is negative 29 over 20. So if we take 10 times negative 29 over 20 plus 10 times, and what was our value for y? 31 over 20, positive 31 over 20. It should give us, we should get 1 right there. All right, so I'm going to move on to another piece of paper here. Running out of room there. All right, so what's 10 over 1 times negative 29 over 20? What's that give us? That's going to give us, well, if we take 10, well, let's just go ahead and just reduce down here. So that's going to give us 1. Make sure I put it over here where I can see it. Sorry about that. So we took, so let me bring it over here. 10 times negative 20 over 20 would be written like this. 10 over 1 times negative 29 over 20. We would reduce down by cross cancellation there. All right, so the 10 and the 20 those cancel out. 10 divided by 10 is 1, 20 divided by 10 is 2, and that gives us negative 29 over 2, okay? So negative 29 over 2 plus, so all of this right here, when we multiply this out, it gives us negative 29 over 2. Now we're going to add that to 10 times 31 over 20. So let's do that. 10 over 1 times 31 over 20. All right, and again, these cancel. 1 and 2. And you get 31 over 2. So plus 31 over 2. Okay, now what does that give us? That gives us negative 29 plus 31 gives us positive 2 over 2 equals 1. And what do you know? It balances out. Wow. I imagine you're looking at this and maybe going, what just happened? Okay, maybe go back and watch that one more time. I think the thing about this problem is that it wouldn't look so weird if they gave you a problem that actually gave you some nice whole numbers here, but because of these fractions, fractions are just ugly, you know. So, well, just go back and watch the video again if you need to. We can talk about it some more. I wanted to do one more of these with you, and then I'm going to give you the problems that you need to do. Okay. All right, here, last one here, last example. All right, now, remember in the last one, or actually the last two, the equations already started off with nice, clean, like x equals blah, 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 or y equals blah, blah, blah. That's not the case here. That's not the case here. So what we're going to do, and you're going to see at least one like this. All right. What we're going to do here is we need to solve for one. Let me put it this way: we need to isolate one of the variables. Now, the easiest one to do that with is going to be this one right here, because if we try to isolate x or y here, then we have to do all this division. We would have to bring the 3 over here. Like, so for example, if we're going to solve just for x here, if we're going to isolate x, that means we would have to bring the positive 3 over here as a negative 3, the positive 6y over here as a negative 6y, then I divide everything by 2. Okay, this one, x is already just x. We wouldn't have to divide by anything to get it by itself. Does that make sense? So let's isolate x right here. What would that look like if we isolated x? Well, it would be, we would take x minus 4y minus 9 equals 0. So we would bring the 4y over here. That would cancel out. And then we would bring the 9 over here. That would cancel out. And so we would have x equals 4y plus 9. Okay? So I'm going to rewrite everything. That's going to be 2x plus 6y plus 3 equals 0. And then we have x equals 4y plus 9. Okay. All right. So now we're kind of back to where we were, right? And so what we're going to do, see if you can maybe think this through for a second. What should we do? What should be our next step? Yes, we're going to take this right here and plug it in for x, because it says x equals 4x plus 9. So we're going to plug that in. All right, so I'm going to rewrite the top equation. We're going to take 2 times 4y plus 9, okay, plus 6y plus 3 equals 0. All right, so now we need to go ahead and distribute here. So where are we trying to go? What's our goal here? We want to, now that we're dealing with just one variable, okay, we have a y. We can actually figure out what the value of y is, so we can take that value of y and go back up here and plug it in either right here or right here. Right? Okay, so that's going to be 8y. Sorry, that is a hideous 8 right there. All right, that 8's almost as ugly as I am, and that's pretty ugly. All right, so 8y plus 18 plus 6y. Sorry, it's kind of hard to write. Plus 3 equals 0. Okay, so let's make sure we did it right. We got 8y plus 18 plus 6y. Now let's go and combine our like terms. That's going to be 14y plus 21 equals 0. Subtract 21 from both sides. It's hard to write when you get further down to the bottom of the paper. Let me use my elbow. Well, I can't do that. Minus 21. Those cancel out. So we get 14. My word. Let me set the phone down for a second. 14y equals negative 21. Y equals negative 21 over 14. Okay, so what we got here is we've got y equals negative 21 over 14. All right, so I'm going to get a new piece of paper. And let's see what we've got here. So let me review what we've already done in this problem. We went ahead and we isolated the x so that we could get a value of x that we could then substitute back into this other equation. All right, when we do that, we get 2 times 4y plus 9 plus 6y plus 3 equals 0. We distribute, gives us 8y plus 18 plus 6y plus 3 equals 0. We combine our like terms, 14, we got 8y and 6y gives us 14y, 18 and 3 give us 21 equals 0. Okay, we subtract 21 from both sides. Remember, we're trying to figure out what the value of y is. So we're isolating, we're getting y by itself. So everything that's not a y, we're bringing it over here, right? So positive 20y would subtract positive 21, we subtract 21 from both sides, and we get negative 21 over here. We're left with 14y here, and we divide both sides by 14. We get y equals negative 21 over 14. All right, so now we're going to bring that, now that we have a value for y, I can actually plug it in. Again, I can plug it into either one of these equations. Okay, so I'm going to use this bottom one here. So let's take x minus 4. Okay, now instead of putting y, I'm going to put the value of y, which is negative 21 over 14. Okay, minus 9 equals 0. Oops, that's supposed to be a 0. Paper's kind of sliding around on me. Okay. Okay. So now we're gonna do this. We're gonna be able to find out what the value of x is because x is our only variable. All right. So what do we need to do here first? We have a negative 4 being multiplied by negative 21 over 14. So we need to go ahead and do our multiplication first, right? That's right here. Well, you got a negative times a negative, which is the same thing as a positive times a positive, right? So this is the same thing as 4 over 1 times 21 over 14. Okay? So we can do some reduction here, all right? Those are both divisible by 2. So we would have 2 and we would have 7. Okay? And then notice here you've got, so this is 2. 2 over 1 is 2. All right. Times, okay, 21 divided by 7 is 3. So this is actually 6. Okay. So all of this right here, negative 4 times negative 20 over 14 actually gives you 6. So don't forget about the rest of your equation though. All right, so now what we got? We have x. We took this negative 4 and all of this right here became positive 6 minus 9, that's that, equals 0. Okay, so now we need to solve for x. So if we combine our like terms, that's x, and then 6 minus 9 is negative 3 equals 0. So we add 3 to both sides. And get x equals 3. Okay, now, so we actually have our two values here. And now we need to check our work. We figured out that y equals negative 20 over 14 and x equals 3. Now let's go back to our original two equations. I'm going to bring out one more piece of paper here, and it's a lot of work. I'm gonna write our values here. So we said that x equals 3, and we said that y equals negative 21 over 14. Another way we could write that as an ordered pair. We have 3 and negative 21 over 14. Either way. I want you to see that because in Ignitia, they may have you looking for your answer in this format instead of this one, okay? All right, so, and then our equations, our original equations were 2x plus 6y plus 3 equals 0, and x minus 4y minus 9 equals 0. So what should happen is when I plug in these values for their variables, I should get 0. So let's try that on the first one. So 2 times 3 plus 6 times negative 21 over 14 should give me 0. Okay, we know that this is 6 plus, okay, I got a little bit of math to do here, right? So we've got, I'm gonna bring all this down here. All right, so 6 over 1 times negative 21 over 14. We can do some cancellation here. These are both divisible by 2, so that gives me 3 and 7. All right, so let's bring this down here. 3 over 1 is 3 times, okay, now check this out. Negative 21 divided by 7 is negative 3, right? Negative 21 divided by negative 7. I'm sorry, negative 21 divided by positive 7 is negative 3. Negative 3 times positive 3 is negative 9. So we're putting negative 9. And then, so don't get lost here. All we did was we took 3, plugged it in for that x. So 3 times, we take that 3 and put it in for x. We get 3 times 2, that gives us 6. Okay? Then we took negative 21 over 14 and we put it in for that y. And what does that give us? That gives us, when we do all that math, 6 times negative 20 over 14 gives us negative 3. So we've got it gives us negative 9. So we've got 6 plus negative 9. Then we got this, plus 3 equals 0. Does that work? Well, 6 plus negative 9, that's the same thing as saying 6 minus 9 is negative 3. Negative 3 plus 3 is 0. So yes, it checks out. This equation, that checks out. All right. Let me get yet another piece of paper here, and let's actually check the second equation here. Again, our, sorry to clear my throat like that. X equals 3, and y equals negative 21 over 14. Or as an ordered pair, we could write that as 3 negative 21 over 14. Okay. So the second equation, if we look at it here, is this right here. So it's x minus 4y minus 9 equals 0. So we're going to plug in a 3 here, minus 4 times negative 21 over 14 minus 9 equals 0. Okay, so we got a little bit of math to do here. So remember, I think we've already actually done this exact one once already, but let's just, so we have our 3 that we've already got plugged in. So let's just do our multiplication here. So remember, that's a negative 4 times a negative 21 over 14. That's the same thing as saying positive. Remember, that's the same thing as a positive times a positive. So 4 over 1 times 21 over 14. Okay, remember 2 over 1 is 2. Times 21 over 7 is 3. So that's 6. So all of this right here gives us positive 6. So I'm going to rewrite, okay, I've got my original, I got my 3 there. all of this right here gave me positive 6 minus 9. 3 plus 6 is positive 9. 9 minus 9 is 0. So this one also checks out. All right, so what this means is that when I plug in my values to both of our original equations, I'm going to bring back the original paper. We did all this work to figure out that x is 3 and y is negative 21 over 14. And when I plug these in, we already did the math. I plug in 3 for x, and I plug in negative 21 over 14 for y. In both of these, I get 0 for both, which means it's correct. Okay, here's the problems I want you to do. I want you to do numbers 8, 9, 10, and 18 in the lesson that's called the substitution method, okay? So we're skipping some lessons, which is fine. These are the ones I want you to do. Everything else, if you turn it in and you get them all wrong, don't worry. I'm going to go in later. I'm going to skip all the ones that you didn't do. And we will talk on Friday about these 4 problems and see if anybody needs any help, okay? Take care.